Alright, so in this video, I'm going to be solving the equation 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. So I'm going to first start by dividing every term by 25 to the power of x. So these two cancel out to get 1. So now I have 9 over 25 to the power of x plus 15 over 25 to the power of x is equal to 1. Now 9 over 25 I can rewrite as 3 squared over 5 squared. And 15 over 25 is the same thing as 3 over 5. So 3 squared over 5 squared is the same thing as 3 over 5 squared. And now I have this to the power of x plus 3 over 5 to the power of x is equal to 1. Now I can actually swap the places of these. So I get 3 over 5 to the power of x to the power of 2 plus 3 over 5 to the power of x is equal to 1. From here, I'm going to let 3 over 5 to the power of x equal to the variable y. So now I have y squared plus y minus 1 equals 0. And if I use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, I get y is equal to negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 1. All over 2, which is equal to negative 1 plus or minus the square root of 1 plus 4, which is 5 over 2, meaning I have 3 over 5 to the power of x is equal to negative 1 plus the square root of 5 over 2. And the reason why negative 1 minus the square root of 5 over 2 doesn't work is because that's negative, and you can't take the power of a positive number and make it equal negative. So from here, if I take the log on both sides, I get log 3 over 5 to the power of x is equal to log of negative 1 plus the square root of 5 over 2. So I get x is equal to log of negative 1 plus the square root of 5 over 2 over log of 3 over 5. So this is my solution. Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3. So I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3 which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation.